In this tutorial, I will demonstrate how to use SignalShow to create mathematical functions that are commonly used in signal processing. All functions in SignalShow are inherently complex, meaning that they have both a real and an imaginary part. Let's start by creating a one-dimensional function by defining its real and imaginary parts. In the 1D menu, select New 1D Function from Real and Imaginary Parts. A window appears that has tabs for Edit Real Part and Edit Imaginary Part. We are editing the real part now. On the left side of this window, there is a list of mathematical functions that are built into SignalShow. Let's click on Bessel to create a Bessel function. We see a description of the Bessel function appear, as well as the plot of the Bessel function. If we scroll through the Bessel function description, we see a description of the differential equations that define the Bessel function, a list of its parameters as it is defined in SignalShow, information about its support, area, and symmetry, and links that we can visit on the web to read more about this function. Let's look at the parameters. We see the amplitude, a sub 0, the width, b, the center, x sub 0, and the order, n. Now let's look underneath the plot. We see parameter editors that correspond to each of these parameters. Here's a parameter editor for x sub 0, the center parameter. To edit this parameter, we can type a number into the box, so I'll type in 30, and we see that the center of the Bessel function shifts from 0 to 30. We can also use the arrows on the side of the editor to shift the function. Here I'm editing the width parameter b. Now I'll hover my mouse over the plot of the Bessel function. We can see three colored lines appear. The yellow line is used to control the center parameter of the Bessel function, so I can click and drag this line to change the center parameter. The green line controls the width parameter, and the red line controls the amplitude parameter. To change the order of the Bessel function from 0 to 1, use the arrow keys or type in a value in the parameter n for order. Here I'm changing the order of the Bessel function, and so I've changed it to 5. To change the type of function being created, we can select something else from the list of functions. This list is also searchable. Let's create a triangle function. So I'll search for try, and the triangle function appears. We can see that the triangle function also has the amplitude, center, and width parameters, which I can control using the yellow, green, and red lines, similar to the Bessel function. Another type of function available in SignalShow is noise. Let's search for noise, and then select Gaussian noise. The Gaussian noise function has three parameters: mu, the mean, sigma, the standard deviation, and a parameter called seed, which controls the seed that the computer uses in its pseudorandom number generator to create the noise. To edit the mean, we can click and drag on the yellow line or change the value in this box. The red line controls the standard deviation parameter, sigma. The samples used to create the noise function are drawn from a probability distribution that has mean mu and standard deviation sigma. If I change the seed from 1 to 2, different samples are taken from the same probability distribution. But you can see that the function has a similar mean and standard deviation, even though the seed changes. We can also edit noise in histogram view. Simply click on the histogram tab to the side of the plot, and a histogram of our function appears. The mean and standard deviation of the noise function can be edited in histogram view. Now let's go back to data view. We've not yet explored the controls at the top of the window. Let's look at the dimension control. This changes the dimension of the function, which is the number of discrete samples or data points in the function. When this value is changed from 256 to 512, we can see more samples, again drawn from the same probability distribution as before, added to our function. Now I'll change the number of samples to 1024, and we have even more data points. And back to 256. Let's look at the effect of this control on a continuous function, such as the sync function. So I'll change to a sync function. Let's say we have a sync function with a width of 4. When we have 256 samples, we can see that this sync function appears to be continuous. But say I change the number of samples to a small number, such as 16. We can see that the sync function now appears to be just a rough approximation of a true continuous sync function. I'll change the dimension back to 256 and the width back to 16, which is the default. Now let's look above the plot area. This is a calculator, which allows us to combine functions with the operations multiplication, addition, and subtraction. Let's multiply our sync function by a cosine. Note that when we edit a function, its thumbnail changes in the calculator. To switch back and forth between functions in the calculator, simply click on their thumbnails. We can also see a thumbnail view of the complete function that includes the real and imaginary parts on the left side of the screen. The real part of the function appears in blue in this thumbnail. Here we can see the product of the sync and the cosine. By hovering our mouse over this thumbnail, we see the equation that defines this function. To look at a larger plot of our complete function, click on the Plot tab. And we can see the real part, imaginary part, magnitude, and phase of our function. For a larger plot, click on any of these small subplots to enlarge it. From here, we can examine the values of our function. Now let's go back and add an imaginary part to our function. Click on Edit Imaginary Part. Let's add a sync multiplied by a sine. Here in the left side of the screen, we can see the red part added to the thumbnail. This represents the imaginary part of our function. Now let's go back to plot, where we can see the real, imaginary, magnitude, and phase again. Here we see that the imaginary part has appeared. From this view, we can change the plotting style and also the color of our plot. To view the FFT of our function, click on the FFT tab. Again, we can change the plotting style and the color of this plot. There are more options available, including histogram and Argand diagram, and a variety of other ways to create one-dimensional and two-dimensional functions in SignalShow. I will be going over these in future video tutorials.